Hello, my little mathematicians. Today we're going to go over the difference between GCF and LCM word problems. Now, technically, you already know how to do these, so what would be great is if you tried them on your own first. So feel free at any time to pause the video, try it, and then unpause it and come back and check with us. So for number one, it says if you have 48 boys and 36 girls, what is the maximum number of teams you can have with the exact same number of boys and girls on each team? What do you think, GCF or LCM? Well, they kind of gave you this really big hint right here when it says what's the maximum number of teams that you can have. It's a GCF problem. So you have 48 boys and 36 girls. So let's find the GCF of those. Well, what can go into both? Those look like 12, because 12 times what is 48? 4. And 12 times what is 36? 3. Nothing can go into both 4 and 3, so that's it. You can have 12 teams. All right. Hopefully you did pretty well on that. Now your ladder could have looked different. You could have started with 2, 6, 3, or 4. And as long as you kept going till you couldn't go anymore, you still should have ended with 12 teams. Let's see how you did on number 2. It says if a store sells hot dogs in packages of 6 and buns in packages of 8, what is the least number of packages of each item I need to buy in order to have the same amount of hot dogs and buns? Is that a GCF or LCM? Well, you're not trying to find the greatest number of packages. You're trying to find the least amount of packages that you can buy that then will have the same amount of each one. So we have 6 and 8. Well, what can go into both 6 and 8? 2 can. 2 times what is 6? 3. And 2 times what is 8? 4. Can you keep going? Nope. So let's multiply all these. You have 2 times 3 times 4. Well, 2 times 3 is 6, and 6 times 4 is 24. So the smallest amount is 24 hot dogs and buns that you can buy. Okay. But it's actually asking about the packages, right? So this one's a little bit tricky because the hot dogs come in packages of 6, right? So if you buy 24 packs, like that's more than, because they don't come individually, they come in packages of 6. So how many times does 6 go into 24? 4 times. So you really want to buy 4 packs of 6 hot dogs. And then how many packs of buns? Well, buns come in packages of 8, and you want to have a matching amount of hot dogs and buns. So how many times does 8 go into 24? 3 times. So really you only buy 4 packs of hot dogs and 3 packs of buns. But then you'll have a matching amount of 24 hot dogs and buns. This one was a little bit tricky, huh? Okay, number 3 says a grocery store is desperate to get more customers and so is running a promotion where every 50th customer gets a $50 Amazon gift card and every 175th customer gets their groceries paid for. What number customer will be the first person to win both the Amazon gift card and have the groceries paid for? So you want to know, let's take a look right here. If the 50th customer, every 50th person gets a $50 Amazon gift card, well, that would be the 50th and 100th and 150th and 200th. All those customers are going to get Amazon gift cards. And then 175 and 175 times 2 and 175 times 3 and 175 times 4. All those customers are going to get their groceries paid for. Well, then who's the first person that's going to win both? Those types of problems are LCM problems. Anything like scheduling, which this is like a type of scheduling problem, they're going to be LCM. So there's a lot of numbers here. I see 50th, 175th, and 50. Well, that 50 is not actually part of it. That's extra because you could have just said every 50th customer gets a gift card, right? We just happen to tell you what the amount is. So it's every 50th customer and 175th customer that we're trying to find the least common multiple of. Well, since it ends in 50 and 75, I'm going to think it in terms of quarters. How many quarters make 50 cents? Two. And then for $1.75, four quarters make $1, and three more quarters make that 75 cents. So 25 times 7 makes $1.75. All right, can I keep going? No, nothing can go into 2 and 7. So let's multiply those. 25 times 2 times 7. Well, 25 times 2 is 50. And 50 times 7, well, 5 times 7 is 35. Tack on a 0. So it's the 350th customer that's going to win both of those prizes first. There's several people that are going to win both, but that's going to be the first person who wins both. All right. The last one says a fruit salad made on a TV cooking program requires chunks of cantaloupe and honeydew. After cutting the fruit, you have 30 chunks of cantaloupe and 42 chunks of honeydew. What is the greatest number of servings you can make using all of the fruit if you want the amount of cantaloupe and honeydew to be equal in all the servings? All right, well, they kind of told you right there, you're trying to find the GCF. So you have 42 of honeydew and 30 chunks of cantaloupe. So you're trying to find the GCF of 30 and 42. Well, what can go into both 30 and 42? I know 6 can. 6 times what is 30? 5. And 6 times what is 42? 7. Can anything go into 5 and 7? Nope. So that's it. You're done. Now, if it was LCM, you'd multiply all these, 6 times 5 times 7, but it's just GCF, so it's the numbers along the outside, which is 6. You can do 6 servings for that one. All right. Over here for this section, I want you to read the example and then mark if it's a GCF or LCM problem. What do you think? Okay, you unpause the video, you're back with us. And it says, I want to plant 6 daisy plants, 8 hibiscus, and 10 plumeria. If I put the same number of plants in each row, and each row only has one type of plant, what is the greatest number of plants that I can put? Well, that sounds like a GCF one to me. Beach coming on a Sunday, Dylan found 30 conches, 15 sand dollars, and 5 clamshells. If he's planning to give them away in sets to his friends, how many identical sets can he make? What do you think? Again, you're trying to find the GCF. Okay, because you can't go over those amounts because those are the only amount of shells that you have, right? So you're not going to do the multiples of them. At the gym, Hillary swims every 6 days, runs every 4 days, and cycles every 16 days. If she did all 3 activities today, in how many days will she do all 3 activities again on the same day? Well, this is like a scheduling problem. So that's an LCM. Okay, the last one. It takes Amanda 14 minutes to climb up the hill and sled down. It takes Alvin 12 minutes to climb up the hill and sled down. If they start up the hill at the same time, how long will it be before they meet up again at the starting point? Again, this is a scheduling type problem. So based upon what we've covered, what type of patterns do you recognize that are asking you to find a GCF? And then what type of patterns did you say in problems that were asking you to find the LCM? Okay, what did you put down? Well, I noticed that if they're trying to find the greatest amount of something or equal amounts of several items, that is a GCF problem. But if you're trying to figure out when 2 or more things will first happen at the same time, then that is an LCM problem. Okay, or obviously like number 2, like what's the smallest number of things that you can get? And so you can go over the amount because you might need to buy more, then that is a LCM problem as well. But the most common ones are going to be scheduling type problems where you're trying to find the first time that they'll both happen at the same time. All right, and hopefully that helped you a little bit determine the difference between GCF and LCM when you're dealing with word problems. Congratulations, my little mathematicians, you got this.